Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Good morning, good afternoon, and good evening, everyone. Welcome to another seminar co-hosted by the ITU WHO Focus Group on AI for Health and Harvard Medical School Department of Informatics. My name is Enzo Ferrante. I'm a researcher from Argentina's National Research Council, collaborating with the AI for Health Focus Group. This webinar, and also the focus group, are hosted under the umbrella of AI for Good, which is the United Nations leading initiative around how can AI help to achieve the Sustainable Development Goals. In previous seminars from this series, we have already been discussing about fairness and biases in machine learning for healthcare. Today, we will continue discussing this relevant topic. Our invited speaker today is Maia Hightower. Dr. Hightower received her medical degree as well as a Master of Public Health from the University of Rochester School of Medicine, followed by residencies in internal medicine and pediatrics at the University of California in San Diego. She also holds an MBA from the University of Pennsylvania's Wharton School. Maia is the CEO and founder of Equality AI, an early-stage investor-backed healthcare startup. She is also the EVP and Chief Digital Technology Officer at the University of Chicago Medicine, leading digital strategy and IT operations. Maia is an expert in responsible AI and the intersection of digital technology with health equity, diversity, and inclusion. She strives to ensure that the value from digital transformation of healthcare is equitable across all stakeholders, including our most vulnerable. Today, Dr. Hightower will talk about responsible AI and machine learning operations for healthcare. If you have any questions during the presentation, please post them using the neural network platform, and we will read them at the end of the talk. So Maia, it's a pleasure to have you here, and the floor is all yours.
Thank you, Enzo, for that incredibly warm welcome. I'm so excited to be here today and share with you some practical tools and approaches to responsible AI and fair modeling that we can adopt in healthcare. So I'm going to share my screen. Here we go. So responsible AI and MLOPs for healthcare, bias reduction, and fair modeling, every algorithm, every time. And so I truly believe that as we move forward with AI in healthcare, that every algorithm, every time ought to be measured for bias, reduce that bias, and ensure that we're modeling for fairness. And I'll start with a brief introduction of what we do at Equality AI, as well as how biased algorithms scale at unprecedented magnitudes. I'll then propose a responsible AI framework and responsible MLOps framework to match, and then share with you practical tools that are free and open source for bias detection, mitigation, and fairness. And this library of resources continues to grow. So we very much are developer first focused and want to understand your pain points in adopting responsible AI modeling, bias detection, mitigation, and fairness into your workflows, and how we can help decrease that friction so that the right thing to do is actually the easy thing to do. So at Equality AI, we believe that data scientists are the newest members of the healthcare team. And I embrace you, I welcome you to our healthcare teams. We empower digitally enabled care teams to achieve health equity through responsible AI and MLOps. And we take a very human-centered approach to machine learning operations, recognizing that each data point in our repository of data is a human experience. It is a manifestation of real-world occurrences, real-world decisions, real-world outcomes, and there's a human at the center of everything that we do. And so when we think about the scale of algorithmic decision-making and its impact by profession, I'm a physician. I see patients still, and in addition to all those other things, I do occasionally see patients. And when I and my patient are sitting, in front of each other and making a decision, that decision impacts one person. I also have many healthcare executive roles over the years, and currently I'm the Chief Digital Technology Officer at the University of Chicago Medicine. So as a healthcare executive, when I make a decision to say implement an algorithm into our electronic medical record, that decision will impact all of the patients with that particular disease state within my organization. So it may impact 100,000 patients. Well, you as a data scientist, and I'm assuming there's many of you data scientists in the community watching today, when we build an algorithm, and that algorithm is implemented into hundreds of healthcare systems, the magnitude of that impact is in the millions, can be in the millions. And there was an algorithm that was found to be biased and racist here in the United States that decreased resources to African-American patients while increasing resources for equally sick white patients. And that algorithm is estimated to have been exposed to over 80 million patients. And so what we do as data scientists has this scale that is unprecedented in the history of medicine, which can go either incredibly wonderfully, but also has that potential for darkness. And so it really is that combination of real world data. And unfortunately, we live in a world where there is bias and it is reflected in our real world data, plus judgment calls that engender discrimination. And so that real world data represents systems and processes and huge variations of institutions. And we often experience racism and stereotypes, and it's embedded in that data set. There is lack of representation amongst our data set. Our minority populations aren't as well represented in the data set. There may be missing data, and it turns out that the more marginalized a patient population, the more likely to have missing and incomplete data, which makes it difficult to create models that adequately reflect those particular populations. And then there's bias in the data collection systems itself. So especially in healthcare data, often that data is being recorded by a third-party person, often a physician or a nurse or a care team member or somebody at the call center or intake who may have their own biases when it comes to the data that's collected. Then we have the data scientist. And the data scientist, in order to answer a question, simulates reality by making assumptions. Lots of judgment calls are involved in the modeling process. Everything from determining which question to ask, deciding which sample to include within a population, applying inclusion and exclusion criteria. So on, and many, many judgment calls, decision points that we don't always make transparent. And so those introduce bias, that combination of real world data and then the judgment calls of our data scientists or data scientist teams, how they engage with stakeholders, introduce bias into our algorithm. And that is codified, that logic is codified and can potentially scale across not just one health systems, but hundreds of health systems, resulting in unequal access to resource, biased decision-making, And in the United States anyway, there's been a lot of talk about implementing regulations to help protect against discrimination from algorithms. So recently, in August of this year, HHS suggested a proposed rule. So it's not a final rule, but it is a proposed rule of non-discrimination and the use of clinical algorithms in decision-making. And so how do we respond to this real world problem? I mean, this is a problem that all of us need to recognize is embedded in our data sets, embedded in our decision-making. Our data scientists don't reflect the populations that we serve and can have a very limited worldview or homogeneous worldview. Well, one way to respond is by adopting a responsible AI framework and machine learning operations process. So the traditional machine learning operations workflow, you start with framing a problem, access to data and exploring the data, architecting and training, stage and deployment, monitor and optimization, maintaining, and then retiring an algorithm. Nowhere in the traditional MLOps workflow are there steps for detecting bias, mitigating bias, and then modeling for fairness within the traditional MLOps workflow. So we've superimposed that traditional MLOps workflow with a responsible AI framework. And the broader responsible AI framework include these 6 components: a robust and reliable system, respectful of privacy, safe and secure, fair and impartial, transparent and explainable, and accountable and responsible. And so at this point, we are very much focusing on the fair and impartial component of a responsible AI framework, while providing solutions that are also, respectful of privacy and robust, safe and secure. And so what we've released we wanted to take the friction out of adopting responsible AI tools for making bias detection, bias reduction, fairness, modeling methods for adopting them. The easy thing to do, take out of that friction. So think about your own experience with developing a model, and there may have been a thought of, I really want to be able to use these new methods. They're not even that new, but incorporate some of the bias detection and bias reduction methods. But I'm kind of stuck. I don't know what's out there. When I look onto GitHub, and believe me, this is what our data scientists and statisticians have gone through. They've gone through the literature, they go through GitHub, and there's a lot of friction. It's not like you don't have a day job, right? So being able to go through all of the literature out there, keeping up to date, as well as the code repositories on GitHub, they're often not maintained. They're often 2, 3, 4 versions of R behind. So a brilliant researcher may have dropped their methodology into a GitHub repository 3, 4, 5 years ago. And so how do we reduce that friction? And that's what our teams have been trying to do, to build a repository of methods that's accessible. And so the open source GitHub repository has specific methods on fairness metrics, bias detection and reduction. And it turns out fairness is kind of hard because there's at least 20 plus and counting different ways to model for fairness. So we've also included a pathway on how to choose the appropriate fairness metric based on the problem that you're trying to solve. And I'll have my chief data scientist kind of walk through this process with you. And then providing recipes. So step by step, how do we implement these tools into our workflow? And as I said, better to have my chief data scientist, Jiwan Chang, describe the tools and the toolkit so that you get a good sense of what is available, free and open source, and how it may be incorporated into your workflow. So I'm going to show a video. She's not here physically, but she is here, and Jiwan is absolutely lovely. She's so excited to share our repository with you.
Hi, my name is Jiwan Chang, and I am a co-founder and the Chief Data Science Officer for Equality AI. And today I'm super excited to be sharing with you the fact that we have launched our website, our manifesto, and our open source GitHub repo. You can find us at equalityai.com. On our website, we start by showcasing our manifesto. Take a quick read and tell us what you think about who we are and what we stand for. From there, you can easily navigate to our GitHub repository by clicking this button. Welcome everyone to the Equality AI Responsible MLOps GitHub repository. Feel free to keep an eye on our repository, or if you like the things that we're doing, show your support by giving us a star. Our repository focuses on fairness-based machine learning, which is basically an attempt to correct algorithmic bias that we unintentionally introduce by the judgment calls that we make, as well as the issues with real-world data. So what is fairness-based machine learning? In traditional machine learning, we start by fitting a model and assessing its performance. Fairness-based machine learning adds two additional concepts to traditional model fitting: a fairness metric, which is needed to mathematically represent or quantify the fairness of your model, and bias mitigation, methods employed to address bias in the data or machine learning models to achieve or increase fairness. Both bias mitigation methods and fairness metrics can be applied in the pre-processing, in-processing, or post-processing of a model. Focusing on pre-processing, the main idea is to train an ML model on a repaired data set. In order to understand whether your mitigation has actually enhanced the fairness of your model, we recommend running another machine learning model, assessing its fairness, then comparing the performance and fairness pre and post mitigation. But fairness-based machine learning comes with its own challenges. Tons of metrics and mitigation methods to understand and look through, little guidance, trade-offs, and if that wasn't complicated enough, the appropriate mitigation methods depend on which fairness metrics, the machine learning model, as well as other characteristics of your use case. To the best of our knowledge, there's no available solution that exists in the literature attempting to tackle this problem. So we conducted extensive literature review and theoretical analysis on dozens of fairness metrics and mitigation methods, as well as a deep dive into and testing of all the existing open source functions. All of this work has been combined into a software framework we're calling Responsible MLOps that walks through each step of fitting a fair machine learning model, and we've provided functions to make running each step even easier. We included the results of our first use case of hospital admission. Through this use case, we demonstrate how we actually selected the fairness metric of statistical parity ratio and reweighting as a bias mitigation strategy to improve statistical parity ratio while maintaining the performance of the machine learning model. To follow along with the code, click on this example right here, or scroll up the top to see all the files in the repository. Now let's walk through the actual code that makes up our software MLOps framework. We're going to start by clicking this code button to download the repository. Once you've downloaded the repository, extract the file so we can see what's inside. After looking at the example, the most important folder to look at is the SRC folder. In the SRC folder, or the source folder, you can see that there are multiple R scripts. These R scripts, or R modules, correspond to a step in the MLOps framework. For example, in step 2, connect to source data, we've provided the modules data prepare and data fetch. If I scroll up to the top and open up one of the source files, like data fetch, this is what I'm going to see. Each module contains a series of functions that are necessary to execute each step of the framework. We've also included comments here to explain what parameters are available for each function. All right, now that I've given some context on how the code is organized, let's jump into RStudio. In RStudio, you're going to start by navigating to the examples folder in the repository that you just downloaded. And I'm going to open that file that's in the examples folder called example dataset nhamcs.r. Start by making sure you have all the libraries that are necessary. If you have the newest version of RStudio, usually there'll be a banner at top that you can click and it will just download all the packages for you. Now we can just run this script section by section, starting with the first line of code that sets our working directory. Then the libraries. Then run the source files. Next, we're going to go fetch our data. The parameters for the fetch data function include the dataset name, as well as the target variable, the protected variable, and the privilege class. Now, because we're doing fairness-based machine learning, at this point, we're going to determine our fairness metric and mitigation strategy. When I run line 69, I'm running the fairness tree metric function. When I run this, it starts by opening up a questionnaire. With every question, I either answer yes or no. As I answer the questions in the function, it will ultimately calculate which fairness metric is the most appropriate for my use case. Now, as I run lines 75 and 76, I take the fairness metric that was output from the fairness metric tree function. That will output the mitigation methods that are recommended for statistical parity, which is the fairness metric that we selected earlier. Now we're going to prepare our data for our first machine learning model. In the data prepare module, the options that are available are a data preparation method based on a published paper by Zhang, multiple imputation, and the number of iterations. We also include a train test split function that allows you to specify the split that you would like. Next, we can fit our machine learning model. In this module, we've included a parameter for random forest versus GBM. We also include other parameters such as the number of trees and the protected variable. And at the very end of this piece of code, we show all of the performance metrics that we are now capturing in our ML result variable. Previously, we used the fairness metric tree function and the mitigation method function to determine which fairness metric and mitigation strategy. Running lines 141 to 148 will now evaluate the selected fairness metric on our model. Lines 151 to 156 will run the mitigation strategy on our model. And the last stage of our framework is reevaluation. So at this stage, you will now be comparing the fairness metrics and the performance of the model before and after mitigation. To see the results of our end-to-end, check out our use case where we share our findings. All of this information, including our functions, are also summarized on our GitHub page. Thank you so much for taking the time to watch our demo. Please let us know what you think, and also a special thanks to our incredible team of statisticians and machine learning experts, all of which this could not be possible. Thank you.
Okay, well, let's give it up for Jiwan. She did a phenomenal job sharing the toolkit, and we wanted to make it extremely practical, especially for those of you that are in programming in R, to be able to access the tools, explore the tools, and understand what's available. So the next phase is developing an actual software as a service solution with a responsible MLOPs studio for developers. So our beta launch of the more slick version, for those of you that that don't use R predominantly, or there's still plenty of friction where you have to incorporate the toolkit within your individual workflow. If you prefer an all-encompassing solution, especially for those citizen data scientists, we are launching a beta version in November of 2022, so in the next couple of months, with a slick interface and essentially all of those fairness metrics, as well as bias detection and mitigation strategies in Python within the MLOps studio. So reach out if you're interested in becoming a beta user. And so I'll end with our Equality AI manifesto and promise, because again, you, data scientists, are the newest members of the healthcare team. And as such, the Hippocratic Oath applies. First, do no harm. Therefore, we pledge to adhere to the following ethical code and swear to fulfill, to the best of our ability and judgment, this covenant. We respect that algorithms have power over life and death, treatment and non-treatment, distribution of scarce resources. This is an awesome responsibility that must be faced with great humbleness and awareness of our privilege. We respect healthcare data privacy and security. We won't lose sight that each data point is a unique human experience, digitally recorded. And we respect the hard-won scientific gains of those in whose steps we walk and gladly share such knowledge. And that's why we actually provide everything, so much of our toolkit available free and open source on GitHub. We will not be ashamed to say, I don't know yet, and we'll call on our colleagues when the skills of others are needed. We value a culture that combines an agile mindset and process with authenticity, personal wellness, and team fulfillment. May we always act to preserve the finest tradition of the healthcare calling. We bring modern technology methods to solve healthcare's most challenging problems: inequity, bias, unfairness. We believe in AI for good, AI that's fair, and AI that's equitable. This is our team. So you saw Ji-Won, she is amazing. Janice, as well as our other co-founders, so 3 co-founders, and our chief technology officer. Can't help but acknowledge our investors who have so much faith in what we are doing. And now I leave it to questions. Definitely, if you have technical questions, feel free to reach out to our development team on Slack. Ji-Won is available if you have specific questions on how to access the toolkit or other use cases that you'd like to see built out step by step. We are here to really help decrease that friction in adopting responsible AI modeling within our MLOps workflow. And that's it. Thank you.
Well, thank you very much, Maia, for the amazing talk, and G as well, who was not here, but she was here with us. Well, so this is a really interesting technical development. I think what you are doing. Actually, it's nice to see that startups and companies are starting to look in that direction that we sometimes look at from the laboratories or research laboratories, but this is going to the real world. This is going to also the industry world. So this is really interesting. I think we have one. I mean, first of all, if there are questions from the audience, please put them on the neural network framework, and we will be reading them from there. So we have one question here from Julian Pani, who is asking if it is possible to integrate the functionality of the open source repository with Python code. I think you mentioned that already a little bit, but if you want to expand a little bit on that. Yeah, I have the same question actually as a Python developer.
As a Python developer, yes. So that is on our product roadmap for the GitHub repository, that it is available in Python as well. So we'll have it, of course, in our studio already, and then in Python. And the way that we're going about it is each of the methods, because there are at least, like I said, 20 plus fairness methods, as well as many bias detection and mitigation methods. So we break down each method by method with that framework of how do you use it, the statistical definition, and you saw the statistical definition, the mathematical definition, and then the code. And we want for each of those methods to be available in both R and in Python. So that's what we're building out. The statistician team is very busy. It's busy with that product roadmap. Now, what we definitely would love feedback on is which methods, because we haven't built out all of the methods yet, but the order. Are there methods that you use every day that are not currently available within our library? And they're also building out a wiki with each of the methods sort of listed out. So sort of further expansion, not only is it going to be available in Python, but it is method by method. So your workflow may be that you just love a handful of methods. You want to pull down from the GitHub repository 5 or 6 different methods and then plug it into your workflow. Maybe you don't want to maintain the code and you just know that it's going to be updated with each version of our Python, and then just periodically check back, download what you need, and continue on your way.
Good. Okay, good to know that then. Yeah, there is also another question from Daniel Benjamin Smoliak. I hope I pronounce it the right way. And he's saying, should data scientists be going through some of the fairness metric questions with colleagues with more health focus? And I think this is really important.
Yeah,
I mean, when I was, yeah, so you can.
And you probably think exactly the same. Yes, data science is a team sport. And so very much encourage our data scientists to engage with key stakeholders, especially the healthcare, whether it's the physicians, nurses, informaticists. So of course, like me, I'm a physician informaticist, to better understand, what are the goals of the question that's being addressed. And so there are many different ways of modeling for fairness, and it may be just a basic non-discrimination. I want to make sure that my algorithm is, meeting the bar for any kind of regulatory non-discrimination regulations that may be coming along. That's fine. Non-discrimination is actually a pretty low bar, but having that conversation, or maybe your team really is about equity and distribution of resources. That's going to be a different fairness metric if you're actually wanting to distribute resources equitably, which is also a different metric than if you want a different fairness metric than if you want the health outcome to be equitable, right? So those are all questions that ought to be addressed by a group of stakeholders, not just a lone data scientist, but definitely whether it's healthcare colleagues, if it's a broader community of stakeholders, what is it that the institution or whoever is developing the algorithm, the goals of the problem being solved are.
Yeah, great. Yeah, I also share this point of view. I mean, it's really important to involve people who are experts in the domain when we are designing this. Actually, if you think about fairness of machine learning, where it originated as a field of research, as a field of research basically. I think it wasn't in the healthcare domain. It was in a different way, like decision making, maybe more legal aspects. And now we are bringing all these definitions to the healthcare domain, and then we may even need to define new metrics. And then there is a question that I have in this case, and is if we have new metrics, would we be able to include them somehow into this kind of framework, into this framework that you are developing?
Oh, yes, absolutely. Absolutely. And then that's where it'd be even working with the research scientist on one, it's a vehicle to scale, right? So the unfortunate thing about research scientists that just publish is that you may publish, and I'm sure your mother, your sister, and all of your colleagues are reading that paper, right? That's in AMIA, American Medical Informatics Association. I'm sure it is like the first thing on Sunday morning that we pick up and read. So it does help to disseminate as well. But absolutely, I think that having that ongoing repository of methods in one place where people can easily see, are there new methods that are being developed and what use case is most appropriate to use that method? And do I have a similar use case? Because, you know, I'm now working with this particular type of stakeholder or this type of problem. I think that is an imperative, that we have as a community, a place that helps to catalog all of these different methods.
Okay, amazing. Yeah, and so far I've been talking as a developer basically, but maybe if I put myself in the place of an expert on the domain, in this case of healthcare, who was attending the talk, maybe when they saw like all these questions there and things with code and these kind of things, maybe a bit far away from them. So I think it would be interesting, Maya, if you can give us like a more concrete example of how like this could be used, like I don't know, maybe thinking about some specific application that you have already seen where people have used the framework, or walk us somehow through an example of how this could be used. Can you think about an example like that? Can you, like, what type of data, for example, we would be using for training the system, and how, like, just making it a more concrete for someone that is not coming from the machine learning or developer.
Yeah, absolutely. So as far as the types of data, probably the one that's most commonly used, whether it's claims data is actually probably more commonly used, and that is what was used in the example, is a open source claims data source. And claims data, for those of you that may not be familiar with different healthcare data sets, claims data is just essentially the billing data that is generated when a claim is submitted for payment. And the way that healthcare works is that this claims data will tell us, you know, a specific code, maybe it's a medication or a test or an intervention of some sort in a standard way. So claims data is a common source of data. The other data that's a little bit even more tangible is EHR data. It's electronic health record data. That's a little bit richer than claims data because it isn't just transactional, like was a lab test ordered and was a lab test billed for, but it will actually show what the lab test result is. So the claims data won't necessarily tell you if what the lab test result is, but the EHR data will. So EHR data is generally more robust, but it's incredibly variable in comparison to claims data. So those are the common data sources. There was a recent paper by a combination of Google and other health researchers that looked at a data set that was around, was it pregnancy? It was, do you remember this paper, Enzo?
Yeah, I don't remember, but I mean, we can then share it on the neural network if you want.
Yes, exactly. I'll have to look it up again specifically, but it was at risk of postpartum complications, and specifically used some of these bias detection and mitigation methods so that they could better predict with better accuracy for minority, specifically Black patients, the risk of postpartum complications. So before using the mitigation methods, it wasn't as accurate at detecting postpartum complications for Black women as it was for white women. It was better at detecting the risk of postpartum complication for white women, and less so for Black women. They used some of these methods, and it was a better algorithm at as a result. And so that's just an example, like in lay terms, of how these methods can be used, is that the outcome is a better algorithm for patients that the algorithms may not be as well developed for a variety of reasons. So I don't know if I did a very good job of that, but
no, but yeah, this is like a clear example of what type of data. I imagine you can use also, I work with images, so maybe you can also use models that work with images with this framework. Is it already like ready for that? You are planning for that for the future?
We are planning that for the future, but we would need to retest each of the methods. So there's a validation phase where we actually do make sure that the method works for a particular data type. And so far, we've been using, claims and EHR data types. In the future, it'll be the one direction of development is in imaging data types. As well as genomic data types. But the types of bias that are prevalent in genomic and in imaging data are different than in EHR and claims data. And so at least that is the hypothesis. And so would need to just further test that and which methods are most appropriate for imaging and then genomic data. Often it's more the initial literature suggests that it's underrepresentation bias, right? That is in specifically genomic data sets where you have you don't have as much missing data, but you have underrepresentation. So in a genome sequence, you're going to have a complete data set. But when it comes to the representation of minority populations, that may be underrepresented within your data set. So you may be missing important signals, important labels of predictors of disease or by having underrepresentation of minority populations.
Yeah. So you mentioned that in the kind of workflow that you were showing us, like underrepresentation as one of the reasons why these systems may be biased. You were also mentioning people, which I think is really important up there, like saying, okay, the vision of the person who is developing this somehow can also touch on how fair the system is at the end of the day. So I think that is also a really important aspect to consider when designing these systems, right? How diverse are our teams, basically?
How diverse are our teams, basically? Exactly. So ideally, our teams would be as diverse as our human population, right? So then would have a mix of ideas on problems to address, would have a mix of world experiences to match when they're doing the labeling process. The labeling process is a well-known and recognized area of bias where the delta between what is the label and real world outcome that you seek can be quite large. And that delta between the label, say cost, and the real world outcome, risk, for some of our data scientists are really well familiar with the fact that in the United States, African Americans spend less healthcare dollars while being equally or even more sick because of historical barriers from racism to just not feeling comfortable with the healthcare system. So some of our data scientists are aware of that because of the historical lived experience, right? Whereas others are not aware that cost and risk have such a wide delta when it comes to certain marginalized populations. And so that's where having a diverse team can really help mitigate that delta, the labeling bias delta between what labels are available in the data set and what is the real world outcome we're trying to predict, which often is not in the data set. Don't we just wish it were so easy?
No, totally. I think this is really important when we start thinking about biases, to not only consider data as a potential source of bias, but also other dimensions as the people who are basically developing these systems, also the models themselves. What can we do with the models, right? How can we, like, algorithmic, I mean, you were telling that there are many algorithmic mitigation strategies that you are trying to implement there. Well, I mean, yes,
absolutely. I mean, in that, so what we emphasize is we're at the beginnings of a journey, and the beginnings of the journey is the pre-processing step, which will address bias that's embedded in the data set. But it doesn't address the processing. So it turns out, as you develop the model itself, you do actually have to go back and check with each of the modeling methods how bias and fairness may be affected. So that's an intra-processing, and then post-processing, once you've released your pristine algorithm into the wild, how it is actually adopted and used. in the wild, and then have that feedback into future refinement of your algorithm. And so ideally in the future state, a healthcare system would have the tools to monitor existing algorithms in production for any drift, including equity drift, fairness drift, and then retrain the model appropriately so that that drift is addressed. So that's a future state. I mean, I, as a Chief Digital Technology Officer, do not have that tool. And I would love for that tool to be developed. Maybe Equality AI will be making that tool. I don't know. But that is the vision of, you know, a full 360 view of our algorithms, where we know that we're addressing the bias in the data set. We're building an algorithm, both pre and inter-processing, and then post-processing monitoring once in deployment.
Yeah, I think, I totally agree. I mean, monitoring is really important. Once you have developed and deployed a model in production, then there may be changes also that are coming with time in, I don't know, the demography of the people who are using the system, or even the machines. If you are thinking about images, I tend to think about images, but it's like you change the machines you are using to capture the images, then there is a shift somehow in the distribution of images, and the algorithm may not be performing well anymore. And so, yeah, this is really important, I think, and would be great to see in these frameworks of MLOps, like responsible MLOps, to be incorporating these kind of tools. Totally. Yeah. There are frameworks that I have seen, like the IBM 360. Like there are other companies also who are developing interesting frameworks. But how would you differentiate? I mean, this particular one, I think, is more targeting healthcare.
Yes, exactly. Right? That's a big difference. Is it's very healthcare specific, recognizing that the type of biases and use cases that are healthcare specific are different than the use cases external to healthcare, and then the data types themselves. So making sure that if we're applying something to, say, imaging or genomic data, that the appropriate tools have really been tested in the rich types of data that we have in healthcare. So I think that's where, you know, having that healthcare focus, we may be able to expand outward, but they're maybe not. I don't know how translatable some of these methods and tools. Like intuitively, I think it's, you know, you and I were like, it must be fine for social media data. I have no idea. I don't know if I even want to know if it works on like social media data or like you know, search engine data or whatever types of data that seems to creep up, where people know a lot about. I don't know, you and I.
Totally. Well, I don't know if there are other questions from the audience. Please keep on pasting here in the chat. Otherwise, I think we have kind of covered a big spectrum of questions and discussions. There is something that maybe we were talking about that before we started the conversation, the seminar today, Maya. And I was curious about that, and you mentioned at some point about how, like, if you can share a little bit also of your experience of being a tech leader as a woman of color. I think this could be like really encouraging also for people coming from like, in that sense, diverse populations, to also say, yeah, we can do that. So if you can share a little bit of your experience in that, it would be great, I think, for us.
Absolutely. And I definitely believe in, you know, encouraging and developing a diverse workforce, but also being really intentional about the pathways that we create. So I was very fortunate early on so I grew up in Berkeley, California, and I was very fortunate to be, you know, in the shadows of a large academic institution like UC Berkeley that very much has strong pathway programs for all students, but definitely students of color, to diversify STEM fields for women, underrepresented minority students. And so I think that I'm forever grateful for programs like UC Berkeley had a partnership program and a MESA program, math, engineering, science program that identified youth as young as 11, 12 in their interest in math and science, and cultivated, that talent onto college, and then even other opportunities that have come along that have been really encouraging. I think one thing that's really challenging for someone that may not fit the archetype of a techie, right? That may not look like Steve Jobs or Elon Musk is saying, but AI for good, AI for everyone. And that right now there's this huge opportunity to diversify, who is participating in developing AI, so that we really are addressing some of these blind spots that I would say right now exist in the tech industry. And so as far as specific, I think of it as a tailwinds and headwinds, there's this framework around being a leader and a woman of color, a Black woman, Black and woman, and I sometimes appear younger than my stated age. I'm actually quite old, but where there's this concept of our identity of having headwinds and tailwinds, and the tailwinds are what allows us to sort of move with the flow. Often people aren't even aware of some components of their identity that give them nice tailwinds. So for example, being a physician, definitely being a physician, it gives me a nice tailwind where I might have some privilege or advantage that someone else who isn't a physician, especially in healthcare and healthcare IT, may not have. And then the tailwinds being that part of our identity that where bias may creep in and decrease some of those opportunities. Tailwind may be, a headwind may be my race or my gender or my age. It's definitely much easier to embrace the tailwinds, and because that's just an easier path. And then for the headwinds, just recognizing when it is that I need to, buckle down and face that that headwind and go for it. So I often know many have asked about imposter syndrome and how do we address imposter syndrome. And it's kind of like, well, for a little while, you just I call it being comfortable with being uncomfortable. We all have to be comfortable with being uncomfortable and lean into the discomfort. And it turns out if you lean into the discomfort enough times, it's no longer uncomfortable. So that's my leaning into the headwinds strategy while riding a little bit of the tailwinds of education, economic privilege, social status, you name it.
Okay, well, I think it's pretty inspiring. So, well, in this, I think we can close the presentation if there are no more talks. We will be available in case you want to discuss more in details with Maia. I will also be online on the neural network in case you want to chat about some specific things. And thank you very much, Maia, for accepting the invitation, for being part of AI for Good. We will now close the presentation with a small video from Anna, the avatar of AI for Good, who will say goodbye. So thank you very much, everyone, and see you soon.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. After the networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.